Okay, good morning, everyone. First of all, I just want to make sure that I'm recording the video, so wait a little bit. So I have sound on, video on, recording on. All right, seems to be good. All right, we finished. According to our syllabus, we finished proportion percentage and percentage problem yesterday, 6.1, 6.3. So I'm gonna do 6.5. 6.5 is application. The video already posted on the module. I'll keep working on video on week number 4 of problem solving formula. 9.4, 9.5, 9.6. Okay. So I'm gonna do video for all the night today. Hopefully I have enough time to cover. Otherwise, I will split it into 2 small videos. And the first video cover 9.4, 9.5, and the second one covering 9.6. All right. So let's get started. So over the past 2-3 weeks, you guys been learning how to solve linear equation. You know what a linear equation look like. During the lecture, I mentioned many things about linear equation. I said a linear equation can be used to model many word application. Actually, when we learn percentage concept, we already learned some of the application of linear equation already, because the portion is nothing but linear equation. Okay. So today we continue with our application on linear equation, how to use linear equation to set up an equation, and we solve for the variable we're looking for. Okay, and we're going to use the information inside the word problem to set up a linear equation. All right, so 9.4. Here and oh yes, I think. So 9.4, 9.4, 9.5, problem solving linear equation. Okay, problem solving and formula. When we learn formula, actually those formula will be used to set up equation. Actually, this formula you already learned, but some of you forgot. But I mean, if we do a quick recall, then I'm sure that you guys remember right away. So first of all, let's go to the formula first. And some very important information you may use to set up a linear equation for the word problem. So we have several shape, a triangle. Okay, and this is altitude. Okay, this is H represent for the height, B represent the base. Okay. So in order to find the area of triangle, this is a half base times height. Okay, a perimeter is easy. Perimeter, we just need to add 3 sides together. Okay. If it is for rectangle, L represent length, W represent width. The area will be length and width. Okay. The perimeter will be add all of them together. So 2L plus 2W. For the circle, center is the radius. Area is pi r squared. Perimeter, circumference is 2 pi r. Okay. For the trapezoid, this trapezoid is the height. B1 is represent the top base. These two represent the bottom base. So the area will be 1/2 time height time B1 plus B2. Okay, and perimeter is easy. Perimeter just again just add all 4 sides together. So I'm not gonna put over there. Anything else? Square. So if you know this is S, so the area will be S squared. So if we know the dimension of one side, then you just square it, that will give you the area. Okay. Perimeter is easy. Perimeter is just 4S, because you add all of them together, plus you 4 sides. Okay. There are another some information you need to know. First of all, for any arbitrary triangle, so for this angle A, angle B, angle C, the sum of interior angle of any triangle, okay, equal to 180 degrees. Okay, so you add all the angle inside the triangle, the interior angle of the triangle of any triangle, it always gives you 180 degrees. Okay. And the last formula is very important also when you are dealing with distance, rate, velocity, and time, which is d equal r times t. Okay, d is distance, r is the rate or the speed, t is time. The unit usually is for second. Over here is the meter per second, and over here is meter. Okay, it could be miles per hour, anything. It depends on the problem. Okay, but remember when you deal with the word problem, unit is very important. So make sure that you have to have unit at the end of your final answer. Okay, so that is general information required you to memorize to start with any word application problem. So number 2, the second problem. So I'm gonna go to the word problem immediately. The general strategy when you do any word problem is that I already said in last time in class, and you have to read the problem and try to understand the problem, use all the number given in the problem, and set it up equation. How you set up equation? You can use the formula here. Okay, you can set up with your own logic. Okay, and the variable in the equation must be the variable representing the one they asking you to find. Okay, so let's jump into the first example I have here. Example 1. All right. state that twice a number added to 7 is the same there you go, is the same as 3 subtracted from the number. Okay, here find that number. So how we do this? You read the problem. It say what? Twice a number. Okay, so we try to translate into mathematical term. Twice a number added, right? Addition, right? 7 is the same. Is the same mean equal? Remember that. Is the same mean equal? This mean equal. As 3 subtracted from, not subtracted by, is subtracted from. From what? From the number. I mean from that number. Okay, find that number. Find the number. All right. So we have to name the variables. First of all, name the variable represent for the number you're looking for. So I'm going to name x. Okay, we'll name x. So let's see. So I name x represent the number I'm looking for. Okay. Okay, the number we want to find. Okay. And the question is, twice the number. I mean, twice mean double. I mean 2x added to 7 added to 7 is the same and equal 3 subtracted from. So subtracted from that number, and that number is x. So subtract from x. 3 by 3. And now what? We have a linear equation. You see that? So we use information in the word problem, set up an equation. Okay. Okay, with the variable we want to find. Then we solve for that variable. 2x minus x, both sides give you x. Minus 3 minus 7, both sides give you negative 10. So the number will be what? Will be negative 10. That's it. So as long as you can set up an equation, everything afterward will be very easy. The hard part is that how you understand the word. And I believe in your reading comprehension skill. You guys must be better than me. Okay, must be. Okay, my English is a second language. Okay, you guys is the first language. You guys must be better than me. Okay, okay. You mean what? Even if I understand it, so can you. Okay, if I can set up equation, so can you. Because it's all about reading comprehension. Okay, it's all about reading comprehension. Some of you in the class is immigrant, but believe me, I'm sure you guys better in reading comprehension. Okay, all right. So that's the first example. Okay, let's jump to the second one. In order to master word problem, you have to do a lot. You have to do many. Okay, how about this? How about this one? There's so many interesting problem, you know. A 10 foot 4 is to be cut into 2 pieces. Okay. Into 2 pieces so that the length of the longer pieces is 4 times the length of the shorter. Okay. So find the length of each piece. Okay. So what do you want to find? We want to find the length of each piece because there's a whole piece. Just imagine a whole piece like this, and they cut into 2 small pieces. Okay. One piece will be longer than the other piece, of course. Okay, because that's what they say. They say what? The longer piece is 4 times the length of the short. So after you cut, you have 2 pieces, right? Shorter and long. Okay, so I'm gonna name it. Okay, I will name it. They ask you to find the length of each piece. So let me name the longer piece. Okay, the longer piece is L. The longer pieces. Okay. We know the total. We know the total is 10 foot. So even after you cut it, the total is still 10 foot. Okay. So the total will be 10 foot. It means the equation will be equal to 10. Because the total is 10. So the longer piece, okay, is 4 times the length of the shorter. 4 times the length of the shorter. Okay. So mean what? It means what? It means that if we have the longer piece, okay, we have a longer piece, okay, you add it to the shorter piece. The shorter piece, the longer piece is 4 times the length of the shorter piece. It means the shorter piece will be L divided by 4, right? Right? Because it's 4 times. Or you can set up in another way. If you can set up another way. If I call, instead of calling L as a longer piece, I call S as the shortest piece. Okay. The total is still 10. Okay, so the shorter piece, the S, plus the longer piece is 4 times the shorter, so it'll be 4S. So either way, you can set up linear equation in terms of longer piece, or you can set up linear equation in terms of the shorter piece. Either way work. Okay, either way work. Okay, let me show the first equation for you. So this one for you. This. Okay, so on the first equation, I have L plus L over 4. L plus L over 4 equals 10, right? So I find LCD. Okay, multiply over here by 4, multiply here by 4. So you have 5L over 4 equals 10. So multiply both sides by 4. Right, so you have 5L equals 40. So L equals 8. Fit. That's the longer piece. Okay, if you have L, it's the longer piece, then the shorter piece must be 2. Okay, you divide by 4. Okay, how about this? Same thing over here. See, S plus 4S equals 10. So 5S equals 10, S equals 2. You see that? Same. Same. But one equation will give you the longer piece first, the other equation gives you the shorter piece first, then the length. The longer piece will be 4 times, so 4 times 2, 8. You know? Same thing. Everything same. So either way, okay, you can set up either way in order to get the longer piece first or the shorter piece first. Okay, remember 4 times, I mean 4 times, I mean 4 multiplied by or divided by 4. Okay, it depends on what variable inside your equation. All right, so that's the second example. There are many, yeah, a lot. Let me see, I can do one more. How about this one? Example 4. A computer science major at at a university has a part-time job working on computer for his friend. Okay, for his client. He charged $20 to go to your home or to office. Okay, to your house or to office, and then $25 per hour during 1 month. Okay, he visited 10 hours. He visited 10 hours home, house, I mean, or office, and his total income was what? His total income was $575. Here, how many hours did he spent working. All right. Seems this is seem like this one is harder, right? But again, it's not really that bad. So the guy, is working on trying to fix the computer for client, and he charged $20 every time you go to your house, and then $25 per hour. Okay, upfront $20 if you ask him to go to your house or the office. Okay, during the first month, okay, he visit his 10-hour house or office, and the total income is 575. All right. How many hours did he spend? So let me call X represent the number of hours. Okay. And he charged what? He charged $25 an hour. So if he worked 2 hours, it would be 50, right? 3 hours would be 3 times 25, right? Then X hour would be 25 times X. Okay. But the upfront, every time you guys request him to come to his house, to come to your house, it's $20. So you add $20 to the amount of money he spent each hour, okay, on fixing computer, and it's equal to total 575. All right, hold on. $25. During the first month, he visited 10 hours. Oh, with this information we have not used, huh? Information we have not used. I think 10. So we have 25x times 10-hour home. Okay, so you have to multiply this. Okay, 10-hour home or office. Okay, because he charged $20 to go to your house, but in the first month he visit 10 hours. Okay, and then you have to multiply 20 by 10. Okay, good. Then the total, okay, the total will be 575. Okay, $25 per hour and $20 to go to your house. Okay, but the 10 hours home or office. Okay, so it is a little bit different. So I say, so maybe I understand. See that I understood it wrong a little bit also. See, I thought that they charge upfront $20 and then then $25 per hour. But it's not like that. Okay, so this is like this: $25 an hour. Okay, and but he charges you $20 to go to your house. And they say during the first one he visit 10 hours. During one he visit 10 home. Oh, see, so I said that's why something doesn't make sense. 10 home. All right, so I got him wrong. He visit 10 home or office. So yes, so that's true. That's right. So he charge upfront $20 every time you go to the your office or your house, and afterward $25 an hour. Okay, but the first month he visit 10 house. So I mean 20 times 10. Okay, plus the amount of money he charged depends on how much hour he's working. Okay, but upfront $20 first. 10 of them will be 10 times 20. Okay, so I wrote down something wrong here, so I need to do it. I thought it's 10 out, now it's not. So it's 10 house. Okay, 10 house, each house $20. So 10 house will be 10 times 20. Okay, so it will be 200. That's 25x equal 570. So 25x. So 575 minus 200. Subtract both sides by 200. So we have 573. 573 divided by 25. which is give you what? 5, so 25, so it'll be 1 time, right? 12, so about 12, 375 divided, so it'll be 150. Yeah, 150 hours. All right. So you see that every word problem, try to read carefully. One word wrong, the whole problem wrong. You see, even me, I wrote down one word, I add another word over here. So I thought at the beginning, it's just like $10 for each time, so it's wrong. He visit 10 home, and each home he charges upfront $20. So 10 home, 200, and he keep charging every hour he work. Right? Yeah, it's quite understandable. You call the plumbing guy. Every time he comes to your house, he charges money already. It doesn't matter that you have a big issue on the plumbing or a bad issue or a small issue. It doesn't matter. Or you call it, or you guys call it an electrician. In order to request him to come to your house, you charge probably $50. Then maybe $20 each hour, something like that. It's quite understandable, right? So that example number 3. Okay, so you see that all 3 examples I have not used any formula provided in the first Roman. So let me see if I can give you another example using those formula. Let's see. How about that? Example number 4. Okay. Okay. Jack can afford enough fencing to enclose a rectangular garden okay, with a perimeter. So they give you perimeter. So they give you a perimeter. It means you have to start with perimeter, 140 feet. Okay. If the width here, if the width of the garden is to be 30 feet, so the width is 30 feet. Find the length. What information they give you, you start with that. So they give you the perimeter, you start with the perimeter. They give you the area, you start with the area. Okay, what is perimeter of the rectangle? 2 length, 2L plus 2 width, right? Add all of them. We have 2 length, we have 2 width. So the perimeter will be what? Will be 140 equal to 2L plus 2 width. And the width they also give you. The width is 30. So you can replace the width over here with 30. Okay. Now you can solve for length. 2 times 30 is 60. Right? PEMDAS, multiplication go first. So for L, just imagine this is X. Linear equation, right? Subtract both sides by 60, give you 80 equal to L. Then L divide both sides by 2, 40. All right. Very easy. Right. So you see that in this example number 4 here, I'm using perimeter formula of rectangle. So it depends on the problem. You know, sometimes you have to use the area if they give you the area. Sometimes you have to use the area of the circle. You have to start with the area of the circle. If they give you the area of the triangle, you start with the area of the triangle. If they give you the angle of the triangle, you start with the sum of the interior angle of the triangle, which is the sum equal to 180. Okay, so it depends on the problem how to give you the information. You know, I cannot give you all the example because there's so many. You have to work on it yourself. Okay, try to expose yourself to a different type of word problem using linear equation to set up. All right. So on this last example number 5, I want to show you how to use the formula d equal rt. Distance equal to velocity times t. You drive a car on the street, right? And you depart from Orlando to Miami, okay? And you start with the velocity. I just assume the velocity is constant. The speed is constant. For example, you driving at 80 miles per hour from Orlando to Miami. Okay. And the distance between Orlando and Miami is about how many miles? I can look it up really quick. I think more than 100 miles, I'm sure. Okay. So given the distance between Orlando and Miami, give you the velocity you traveling, you can find the time, the amount of time spent on driving. Okay, I'm not talking about you know you have to stop the car and take a look, and you know, I'm not talking about that. I'm talking about a case when you keep driving. Okay, you are the car on the way all the time from Orlando to Miami. Okay, so that is the typical example of how to use d equal to rt. Of course, some problem is harder than that. Okay, and you have to set up a little bit harder. The equation is also harder. Let me see. I can give you some problem like that or not. Let me see. Okay. How about this? Find how long. I think this is not really that hard with this problem. It takes, see, by the amount of time spending, Peter to drive 130 miles on I-10 if we merge onto I-10 at 10 a.m. and drive non-stop. Okay, non-stop, no taking leg. Okay, with his cruise control set on 60 miles per hour. All right, now we do this. All right. So they ask you to find how long, the amount of time. You see the distance they already give you, right? It's 130 miles. They ask you for t. they give you the speed, because the rate is 60 miles per hour. Okay, they ask you for the amount of time travel. Okay, so easily you just plug them in. 130 miles equal to 60 times t. Then you can solve for t easily. So 135 divided by 60, which is how many? See, around 2.25 now. All right, 2.25 now if you do quick division. Okay, so remember, I can add another question. I can say that at what time Peter finished the traveling. Okay, remember he start on I4 at 10 a.m. and check him 2 hours and 25 minutes. So he will be ended up at what time? At 12:25 p.m. Right? 12:25 p.m. Around 12 at 12 p.m. and 25 minutes. Okay, basically you just add. All right. So that is how you use d equal to RT. Okay, I'm not going to give you some other problem other than this. D equal to RT is very useful formula. Okay, and the word problem will be harder than this, but I think I'm going to just stick to the standard. That's all you guys need for this course. Nothing else. All right. So I think I'm going to stop our lecture over here. Again, for example, I mean, I can tell that it's not enough for you to be good at word problem. You have to do more. But you see that in each problem, I introduce a different concept, how to use a formula, how to use the perimeter area, and the one that you don't have to use any perimeter or area formula. Okay, but I mean, try to work on the problem, keep working on the homework. Okay, if you guys have any question, let me know. Don't hesitate, just send me the message through Canvas. Don't email me, because I receive like 50 email per day. So I mean, I don't want to miss any email. Okay, then I'll be seeing you next time. Bye bye.